Hello, dear students. This is your professor, Lázaro Pino, and today we are going to study organic chemistry. In the lecture of today, we are going to see the different functional groups, how to name compounds, and some of the characteristics of this element. Carbon is a chemical element with a symbol C, an atomic number 6. It is non-metallic and tetravalent. Carbon can make the 4 electrons and be able to form covalent chemical bonds, as you can see in the figure. Life is based on carbon. Organic chemistry studies compounds in which carbon is a central element. The properties of carbon make it the backbone of the organic molecules, which form living matter. Methane is a gas that is found in small quantities in air. Methane is the simple hydrocarbon, consisting of one carbon atom and 4 hydrogen atoms. The carbon atom has 4 valence. The outermost electrons, as you know, because each carbon is equal to the others, they all have 4 valence electrons, so they can easily bond with other carbon atoms to form long chains or rings. Here you can see different chains in ethane, propane, butene, and also you can see branching like methylpropane or rings like cyclohexane and benzene. What is a hydrocarbon? A hydrocarbon is an organic chemical compound composed exclusively of hydrogen and carbon atoms. Hydrocarbons are in the natural environment in form of oil, natural gas, or coal. All of them can be used to produce energy while they are burned. In organic chemistry, an alkane or paraffin is an acyclic saturated hydrocarbon. In other words, an alkane consists of hydrogen and carbon atoms arranged in a three structure in which all the carbon bonds are single. The general formula is the one that you can see. Some examples of alkanes are methane with only 1 atom of carbon, ethane with 2 atoms of carbon, propane with 3, and butane with 4. To name a compound, it's very important to know the number of atoms of carbons because the prefix that is used to name a compound depends on the number of atoms of carbon, as you can see in this table. 1 atom of carbon, the prefix is meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, and so on. So the names of the alkanes are methane, 1 atom of carbon, ethane, 2 atoms of carbon, propane, 3, butane, 4, pentane, 5, and so on. This is the general formula, and this is the structural formula. The alkyl groups are those ones that can be in the chain as branches. For example, CH3 is methyl, CH2 is ethyl, and so on, as you can see here in this table. How do we construct the branch name? Well, first of all, you have to determine which one is the longest chain that we call the parent chain. And then we recognize the different substituents that are the branches. The substituents change the ending "ane" in the alkanes by "il", and in this case we can see that the main chain, the longest chain, it contains 4 atoms of carbon. So this is butane. But you have a methyl group in carbon number 2. How do we put the rest of the name together? Well, we find the longest continuous chain of carbon. In this case, is this one. The longest chain has 10 atoms of carbon. So the parent name in this case is called decane. And then you recognize the different alkyl groups. In this case, you have 1, 2, 3, 4 methyl groups and 1 ethyl group. You begin numbering the atoms of carbon according with the number of substituents could be lower. For example, this is the correct one because you have here 3, 3, 5, 5, while here is 3, 6, 6. You choose this where the atoms of carbon are closer to one of the end of the substituents are closest to one of the end of the chain. So the name of this compound will be 3-ethyl 3, 5, 5, 8 tetra because you have 4 methyl groups and the cane that is the parent chain. Then the 3, 5, 5, and 8 is according with the position of the methyl groups. As you can see here, you have a methyl group in 2 in 5, and you have here 1 in 8. And the ethyl group is in atom 3. That's why you say 3-ethyl 3, 5, 5, 8 tetra methyl decane. Here you have more examples. In this case is 2, 3 because are the position where the methyl groups are, and then you say di because you have 2 methyl groups, And the longest chain in this case it has 4 atoms of carbon, then is butane. In this case, the two methyl groups are in the same atom of carbon, then it is 2,2 dimethyl butane. What are cycloalkanes? They are saturated hydrocarbons, alkanes in this case, whose carbon chains form complete loops. This is the cyclopropane, cyclohexane, cyclobutane, and cyclopentane. Carbon atoms can form single, double, or triple bonds with other atoms of carbon. Carbon can form up to 4 bonds. This allows carbon atoms to form long chains, almost unlimited in length. Here you can see a single bond. Here a double bond between 2 atoms of carbon, and here a triple bond between 2 atoms of carbon. The bond that is face to face is a sigma bond, but those that are not face to face, that are in the space, are between the p orbitals, are called pi bond. In this case, this molecule has a sigma bond and 2 pi bond, a triple bond between 2 atoms of carbon, so this is an alkyne. You can see here the single, the double, and the triple bond, how it's represented in a molecule. The alkanes contains only single bonds between atoms of carbon, but the alkenes contains at least a double bond, and an alkyne at least a triple bond. Here you have examples of this molecule. The alkenes, for example, can be ethene. Eth is a prefix that indicates that you have 2 atoms of carbon, and ene is the ending for alkenes. Propene, 3 atoms of carbon, and the ending "ene" because you have at least one double bond. Butene, because you have 4 atoms of carbon, and pentene because you have 5 atoms of carbon. These compounds can make isomers that are molecules or polyatomic ions with identical molecular formulas, that is, the same number of atoms of each element. But the arrangement of the atoms in the space are different. So the properties and the physical characteristics can be different too. You have here the example of the cis 1,2-dichloropropene. And we say cis because the 2 atoms of chlorine are at the same side of the chain. In this case, they are in opposite positions, so this is a trans isomer. Alkynes contains at least a triple bond. Here we have ethine with 2 atoms of carbon, eth, propine, 3 atoms of carbon, prop, butane, 4 atoms of carbon, but. Benzene is an organic chemical compound with molecular formula C6H6. The benzene molecule is composed of 6 carbon atoms joined in a planar ring with 1 hydrogen atom attached to each atom of carbon. Because it contains only carbon and hydrogen atoms, benzene is also a hydrocarbon. Here you can see different compounds that are in the family of benzene. All of them are aromatics compounds. Here you have phenol, toluene, aniline, anisole, and so on. All of them can be used in as diluents of paint, or also can be used like acetophenone in medicine. The benzene is used for dyes in the pharmaceutical drugs. They can be used as lubricant, is a paint remover or thinner, is also used in the production of rubber for shoes and tires, in aftershaves, lotion, and so on. Alcohol is a group of organic compounds that are characterized by the OH group. When the OH group takes the position of one of the hydrogen, we are in front of an alcohol. If the alcohol group is attached to a carbon that is at the same time bonded to one atom of carbon, we say that this alcohol is primary. But if the OH is bonded to a carbon that at the same time is bonded to 2 atoms of carbon, we call this secondary alcohol, and in this case is tertiary because of the 3 atoms of carbon bonded to this atom of carbon. Some examples are methanol, meth, because only one atom of carbon, and all because it's an alcohol, ethanol, and 1-propanol. Alcohol contains or the OH group that makes possible that these compounds can be soluble in water due to the hydroxyl group in alcohol that is able to form hydrogen bonds with water molecules. Most of the alcohols with the lower um, molecular weight are soluble in water, no the heavier ones. If we compare uh, alcohols with alkanes, we can see that the boiling point of the alcohols with similar molecular weight are higher than than the corresponding alkanes. Why? Because the hydrogen bonds that alcohols can make with water. Ethers is a compound that contains an oxygen between two atoms of carbon. Here you have the diethyl ether, and here the methyl propyl ether. The way we must name the ethers is using the alkoxy groups with shorter carbon chain is a substituent. The longest carbon chain is the parent chain. The substituents are placed alphabetically. In this case, you have the atoxybutane, methoxy for methyl pentane. Here you have the comparison between three atoms, the three molecules of alkane, ether, and alcohol with similar molar mass. As you can see, alkanes contains only dispersion forces intermolecules, while ether has weak dipole and alcohols present hydrogen bonding. This is the reason the type of intermolecular force is the reason of the differences between the boiling point in the different compounds. The oxidation of alcohols can be different according with the type of alcohol. A primary alcohol has a first stage where the alcohol is oxidized to an aldehyde, and later the aldehyde can be oxidized to a carboxylic acid. The secondary alcohols only can be oxidized to produce ketones. Ketones cannot be oxidized. And the tertiary alcohols cannot be oxidized at all. The aldehydes that are produced by the oxidation of primary alcohols are methanol, ethanol, propanol, and 2-methylbutanol, as you can see here, as examples of this type of compounds. The ending of these names are al, corresponding to aldehydes, and the prefix correspond to the number of atoms. In this case, meth, one atom of carbon, methanol. Ethanol, because of two atoms of carbon, propanol, three atoms of carbon, and so on. As you can see, in aldehydes, one atom of carbon at the end of the branch of the chain, is a has a double bond with oxygen and a single bond with hydrogen. This is characteristic of the aldehydes. In ketones, the carbon is attached to a double bond with oxygen, but is bonded in both sides by two other carbon. Here you have propanone, prop, because of three atoms of carbon, on, because it's a ketone. Butanone, here is a mistake, butanone, because you have 4 atoms of carbon. And here you have pentan 3, because the carbonyl group is in carbon 3, and on because it's a ketone. Then the functional group of a ketone has a carbonyl group and 2 carbons beside this carbonyl group. Then aldehydes have the form of CHO, while ketones have the form of RCOR. Aldehydes are more reactive than ketones. They can undergo oxidation forming carboxylic acids. Ketones cannot be oxidized. Aldehydes always occur at the end of a carbon chain. In the case of ketones, always occur in the middle of the chain. Aldehydes usually are found in volatile compounds, while ketones usually are found in sugar. The carboxylic acids, if you see the one carbon is bonded to an oxygen and at the same time to an OH group. This is the characteristic group of carboxylic acids. The carboxylic acids are the organic acids. We have here, for example, ethanoic acid, 2 atoms of carbon, a butanoic acid, 4 atoms of carbon, and so on. The common name here for this compound is propanoic acid, and is also the name used by the IUPAC. But as you can see, is in the other compounds, there is a difference between the common name and the IUPAC name. Carboxylic acids have high boiling points if we compare to other substances with similar molar mass. Boiling points increase with molar mass. Carboxylic acids having 1 to 4 carbon atoms are completely miscible in water, but the solubility in water decreases while the molar mass increases. Here we have the esterification reaction. It's a reaction between a carboxylic acid and an alcohol. The products of this reaction are an ester and water. In order to make an ester, we use a catalyst that is an acid to avoid that this reaction goes backward. The esters are found in the fruits and the flowers, as you can see in this figure. In order to name an ester, you begin by the group, the methyl group that corresponds to the alcohols. The alkyl group in this case is a methyl group. And then the ending "ic" of the acid is changed by 8, as you have in the inorganic salts. In this case, it's methyl propanoate. Amides are similar to alcohols in the structure, except that instead of having an OH, you have a nitrogen group. You have the acetamide, the hexamide, and so on. Amines are compounds that come from ammonia. Ammonia is NH3. If you change one atom of hydrogen by one atom of carbon, you get a primary amine. If you change two hydrogen by two atoms of carbon, you have a secondary amine. And if you have three atoms of carbon, this is a tertiary amine. Amines are important compounds that can be in the neurotransmitters in our bodies. Here you have different amines and the corresponding names. You can stop the video at any time and see the IUPAC name, that is the one that we are going to use in class. So, in the class of today, we studied the alkanes, the alkenes with double bond, alkynes triple bond, the alcohol with the OH group, the ether that contains an oxygen between the two atoms of carbon, the aldehyde with this functional group, and the ketones with a carbonyl group between two atoms of carbon. The carboxylic acid that contains a carbonyl group and an OH attached to the same atom of carbon. Esters are a result of the reaction of an alcohol and an acid. The amines can be primary, secondary, or tertiary if one, two, or three atoms of hydrogen in ammonia are substituted by carbonyl groups, by alkyl groups, sorry. The amide is similar to an acid, but instead of having the OH group, contains a nitrogen group. Please, now you should go to the lab in your manual and answer the activities corresponding to the organic chemistry lab and send me as soon as possible. Also, answer the following questions and send me with the report. Compare an alkane with an alcohol according with the boiling point and solubility in water. Explain the difference between these two organic compounds groups. Name and draw an alkane of linear structure and 6 atoms of carbon. And draw the structure of an alkene of 3 atoms of carbon. Thank you for your attention.